Hello guys, today I want us to go through this paper. I have a question here which reads, study the following reaction scheme and answer the questions that follow. This is a question from the test for cations where you have been given solution C. A few drops of sodium hydroxide solution, it forms a white precipitate D. This is the test for cations. If you know the use of this sodium hydroxide solution, then if there is a white precipitate, then the likelihood of the cations which are present, we have zinc ions, aluminium ions, and magnesium ions, lead 2 ions. We can also have the likes of barium ions and calcium ions. You go to the next step, where now we are adding excess of sodium hydroxide solution. In this excess of sodium hydroxide solution, and then a colorless solution is going to be formed. A colorless solution is going to be formed where now we are going to have zinc ions, aluminium ions, and lead 2 ions present. There is a likelihood of one of these cation being present because the white precipitate dissolves to form a colorless solution. And the reason as to why this white precipitate is, remember these white precipitates are zinc hydroxide, lead 2 hydroxide, and also aluminium hydroxide. The reason as to why these three hydroxides are dissolving on excess of addition of sodium hydroxide solution is because all the three hydroxides are amphibaric. So because they are amphibaric, they are going to react with sodium hydroxide to form the complex ion. They are going to form the complex ion. So it is because of the amphibaric nature of the three hydroxides that's why it is reacting with excess sodium hydroxide. So for up to this step, if we go this route up to this step, you cannot be able to tell actually which cation is present. So but we have a clue now. We have the possibility of one in these three. If you have this colorless solution and then you go this route, you add drops of ammonia solution, you are going to form a white precipitate, same to this one. And then on excess addition of excess aqueous ammonia, we are going to have a colorless solution G. What learners need to know is it's only zinc 2 ions, where it's only zinc in which the white precipitate which was formed up here, which dissolves in excess of aqueous ammonia. So this is zinc hydroxide plus aqueous ammonia. We are going to form zinc tetraamine zinc 2 ions. Yeah, positive plus of course 2 hydroxide ions. So this is the complex ion which is being formed, which is the colorless solution now. So now we have eliminated lead 2 ion and aluminium ions. Remember, for lead 2 ion and aluminium ions, on addition of excess aqueous ammonia, we are likely to form the white precipitate which is insoluble. Now we go direct to the questions. So learners, I always advise learners, whenever you've been given the flowchart, go through the flowchart, try to interpret it, analyze it. The cation in solution C, then we have found it is zinc 2 ions, and then the white precipitate E. Where is the white precipitate? We have here, so we are going to form zinc hydroxide. Remember, ammonia dissolves in water to form ammonium hydroxide. So it is the hydroxide ions from the ammonium hydroxide which is going to react with the zinc 2 ion to form zinc hydroxide. Why does the precipitate E dissolve in excess sodium hydroxide solution? We have said because it is amphoteric in nature. Write the formula of the complex ion formed. We can write all the formulas of the complex ions formed. The first one is tetrahydroxo zinc 2 ion. We have here like that. We have 2 minus. Also the one of G, we are going to form tetraamine zinc. So here we have 4 zinc 2 ion with a positive charge.